Hello again and welcome to this 3D bar chart video. So if you missed the last video, we just went through all the binning sections, so I'm just gonna go pretty fast through that and reuse what we already done. So let's go and create like a T table that's gonna be a pd.read CSV, and we're just gonna call our file that is Twitch data update, I think. .csv. From here, just to remind you what it looks like, we're gonna check it out. Oh yeah, of course, I need to rerun everything. And here we are. So as a reminder, this is a database about like viewing on Twitch, and what we want to do today is use binning to put peak viewers and average viewers into categories, and then use those two categories to create a bar chart that's going to be 3D and comparing like peak viewing versus average viewing and their values. So let's go with that. Let's first check on our values. So t.describe, and this is interesting because we're gonna have informations about the column we're gonna use. So we're gonna use peak viewers and average viewers, and you can see that we've got like 1,000 values, and it goes from 496 and 235 up to 600,000, so more than 600,000, and here more than a million. No, my bad, more than 150,000, kind of. So those are our two or four min and max values that we're going to use for our binning as a reference. Everything else we're going to forget for now and just go along with the code. So first we're going to define our first bin list, and this bin list is going to be so 0, 500, 5,000. Then let's go straight to 10,000, 100,000 and 200,000, and this is going to be for our average viewers, okay, because the average being lower, we don't need to go that high. Okay, the bin's name are gonna be simply 1, 2, 3, 4, 5. We need, here we have 5 values, 1, 2, 3, 4, 5. It's always the same amount of values as your bins minus 1, because obviously this is 1 bin, 2, 3, 4, and 5. Okay, so this is it, and now we're gonna simply create a new column in our table, and we're gonna call it the average size. And we're gonna do a pd.cut for the binning. Again, check on the previous video. And we're gonna do that with average viewers without an underscore. And the bins are gonna be the bins list, and the labels are gonna be the bins name. So now let's check on the t.head. And here we are, we have the average size on the right, and you can see that those top channels are within the top tier, like values, right? We've got like 3, 4, 4 categories, meaning that those guys are not necessarily the guys with the biggest average viewing, but maybe the guys with the biggest like peak viewing, so we'll see that later on. Now we're going to do exactly the same thing, but for the peak viewing. And for the peak viewing, we're going to do basically the same thing. So let's be lazy and copy and paste. And instead of our values up there, we're going to go with this. So let me copy and paste to be faster on my test code. 0, 500, 5,000, 10,000, 100,000, and 700,000. I'm not really sure if the categories are okay, because this is peak viewing, so maybe, you know what, let's get that a little bit bigger. Peak viewing should be more significant, so let's make it more significant. 10, let's make it here 50,000 or 5. Let's make it, yeah, 100,000 right away, then 300,000 and 700. Let's see how it goes this way. Same thing, we're gonna have five bins as a name, okay? And now we're gonna create peak size, and we're gonna use not the average viewers but the peak viewers to finally do the bins, and we're gonna use bin list and bins names. Let's go ahead, and you can see that we still have the previous column, and now we have the peak size, and you can see that the table was sorted with peak size because everything is category 5 here. Okay, so our bins are ready, so now we can start like doing our 3D bar chart, and this is like gonna be pretty fast in the end. So first, let's like group by our values so that we have the actual like population of each categories. So we're going to create a new table and we're going to call T group by. So maybe I should have used like more explicit names, but this, like, I wanted to make something like simple and quick, and I didn't end up being that thorough. So I don't know if anyone was bothered by that. Tell me. I'm never quite sure of what to do for a video. I mainly do it for myself, but you know, it can be pretty nice for you guys to get some help sometimes if I can help, you know. So here we are. So we are grouping by average size and peak size, so the two columns that we created, and we're going to count the values. So what we want to do here is have like the amount of channels that are in those categories. Maybe I should show that to you. So let's show off n, and you see that we're getting this word table with a double index. So you've got the first index that's average size and the second index that's peak size, and so it's always going to be working in layers like that. So you're going to have all the peak sizes in the average size 1, all the peak sizes in the average size 2, etc., etc., making a table that's very hard to use. So what do you do with this? Well, what you can do is call it an of double brackets channel, because channel channel is here. We're just going to keep the one column, and now call n. Okay, now we have something a little bit better. We have this value that we just need the one column, right? Because we had the same values everywhere since it's a count. So we just keep the one column, but we still have this index that is not very useful to us. So we're just going to use n.reset index in place equal true. So remember that some methods in pandas that you're going to apply to your data frame, you can use in place so that it's going to change things within the table, and you don't have to associate it with something else, or you're not creating like another table with it. You're actually performing the change in this table right now. What do we have now? Well, nothing. Call n. And boom, resetting the index did this. Like, what basically pandas, from what I understand, added a new index 0, 1, 2, 3 up to the last value, transforming the dual index we used to have into two different columns. So it means that previously, when we had just the one section and all the subsections, we now have 1, 1, 1, 2, 1, 3. So it's a combination. It's now the two informations we want to use for our x-axes. Okay, and from this place, I just want to sort it real quick. So we're gonna do a sort.values. And we're going to sort it by the only column we care about right now, which is channel. And we're going to say ascending equal false, sorry, not true. And we're just going to keep the head of this. Okay, and we're going to see this better. Okay, so here we are. You can see that we have the categories like size 2 of average, but peak 4 that is the most prominent, showing that like mainly some channels just like peak like crazy but don't really keep up to that. And you can see that the only ones really reaching 5 though are the category 4 average size, so it still shows that there's a cap to what you might be able to do. But let's visualize this. First, I just want to record the length of my table, just real quick. So we're gonna say x length of n, and so yeah, this table is now 25 values long, and we're gonna go with finally our table. So our figure, sorry. So the figure, we're gonna call it fig for figure, and we're gonna say plt, so matplotlib, sorry. For any curious people, we imported it at the beginning, matplotlib.pyplot as plt, and we're gonna say plt.figure, and we're gonna set the fig size to 20 and 10, which was what I tried earlier. And then we're gonna call the axis ax, and this ax is gonna be a figure that we're gonna add to this subplot. So we're gonna add to fig, so the figure we created, we're gonna add a subplot. Okay, this is working this way because doing this, you can add layers of figures in the same plot, in the same figure. You could have like four different values. Like you could have this kind of plot with like a bar chart here, a pie chart here, and some line chart here, for example. But you could also have something like a map, you know, like a country or a state, and in this you could have like dots for a position and like some statistical points in some important places, for example, and adding layers of informations on the same figure. So that's how you can be using this. So now in this subplot we're just gonna say 111, which is a code, and the projection is gonna be equal to 3D. I don't remember for the 111, it's just something I saw in the documentation, so like we're just writing it down. And then plt.show. So what we're gonna get here is an empty bar chart. Oh yeah, that's for a bar chart, sorry. So the projection 3D bar chart. Let's check it out. And it's not working because unknown projection 3D. Yeah, small case d. Here we are with the template for what our figure is going to look like. So you can see that by default it goes from 0 to 2. And there's one issue for me in this layout. It's that we're going from 0 to 10, or 1, sorry, and 0 to 1. Meaning that it's going to cross our informations in a weird way, because you're going to have in this corner the top channels of, I don't know, peak viewing, and the lowest channel of average viewing, and it's not very like I want to converge towards peaks and lowers. So let's we're gonna have to switch that, and then we're just gonna associate those values to our table columns. So let's go ahead with this. So we're back with our figure, and in this figure we're gonna add we're gonna add in, sorry, let me just recreate it so it's clear for everyone. Here we're gonna create a new ax, and this time it's gonna be fig.add subplot. We add the code again, projection equal 3D, small d this time. This way I won't have to go back up to show the code to you. And okay, and here we're gonna have to set up a few things. First thing is gonna be our x value. So we're gonna call it x3 equal. We're gonna have to set our y value, y3 equal. Our z value equal. Just calling them 3 to still remember we're in the 3D chart. So those values are going to be those axes, okay? the axes, well, what do I know? So for example, if we want this to be the average size, well, we're going to add n average size here, and then here n peak size. Then z3 is actually going to be the height at which the bar charts are going to start. And this is pretty complicated to understand, but if you start at height 0, it means that, for example, you're going to have the bar starting here and then going up like that. But if you start at height like 1 or 0.2, for example, then your bar is going to start here and then go up there. So this z value allows you to place your bars even like from their root upper on the bar plot, and it could mean anything. Like for example, you could have a box that's like when it's where it starts and where it goes, and have like those box plots things. I forgot the name right now, but that's not the topic for today. So this is just gonna be zeros, okay? So because we're always gonna start at 0. So we just said what? That this is gonna be n dot one of our columns. So let's say average size. Then y is gonna be n of peak size. And finally, z3 is gonna be just a numpy series of zeros. So let's do that. np dot zeros, and we're gonna make it from our length, the same length as our table, which was x that we just created before. So that works out. Then we're going to need a few more values for the height of our table. And this is where comes the dx value, the dy value, again, calling back to the data just above, dz value, and then we're going to add all those things into my ax dot bar 3d, and then x3, y3, z3, dx, dy, and dz. And then we're just going to choose a color, and it's going to be like red. Okay, so this is basically what I have to do. What is dx, dy, and dz? Well, it's the thickness of your bar. So if we get back up there, remember I told you, depending on the z value, you can make your bar start here. But it doesn't have to cover all the length of this space. It can also be shorter. It could be just like that, or it could be just very, very small, or you could have something that's like intermediate. And same thing on the other axis, you could have something very thick, or something very thin, or something average, so that in the end your bars are going to look very different depending on what you chose as a dx and dy and dz. So those are like thicknesses values. But dz, well, if dx is this and dy is this, well, dz is just simply the height of your bar. So this is where you're going to put the values of your columns that you want to create your bar, right? Simply. So this is the most interesting part for you. So that means what? That dz is going to get n of channel to get the values. Remember, we use the channel column as a random one just to keep on the count of channels. And then those are just going to be like a single value that's going to be the same for everyone, and that are going to be used to populate and make your whole figure homogeneous. But you could use a value of the table to feed those values. It's just like I didn't find an idea for it, so I didn't bother. So np.once, and we're going to populate the amount of rows, so x rows. Okay, so we're going to create 25 ones, and those ones I'm just going to multiply it by 0.5 because I don't want my bars to be 100% width. I want them to be 50%. And we're going to do the same thing here. And just to show it off, maybe make it a little bigger. Okay, so here we are. We have all the values for our bars. It's a bit more dense than for a 2D because you have 3D values, 3D representation, and pandas and matplotlib are allowing you to showcase data using any spatial value of your bars, hence all those 6 possibilities. So now maybe we could just do a plt.show to see what that does. And here we are. You have a 3D pie chart. We're there. We did it. So you can see that as expected on Twitch, things are pretty drastic. You've got the big channels that are very big. But what's interesting is that those channels in number 2, there's a lot of channels actually having big peaks, like being at 4, that are very impressive compared to their size, like their size 2, and they peak to like category 5, so it's pretty insane. But now let's make this a little bit more readable because see, we start like it's pretty weird in the layout and I don't like it. So now we're gonna change it. So we're gonna say our axe is gonna change. We're gonna set labels. So the Y label is gonna be peak views. That's what we're gonna call it. So this is how we add a axis name, and ax.set set x label, sorry, and this is gonna be average view. Yeah, this is okay. So now let's try it again. Okay, and we see average views against peak views, and it's already a little easier to read. And you know what? We don't need this here. And finally, the switching, because remember, I don't like the fact that we're starting from one here and starting from one here. I want it to be converging towards the 2 biggest values, the 2 biggest like categories. And I found a way to do this. It's still in our ax value, which is, remember, the subplot, and we're gonna say a view underscore init, and this is like accessing the all the data that are making your chart, and those are stored as not a JSON file but a dictionary, so you can affect it in a lot of ways, but simply we're going to do an ax.elef and ax.azim plus 90. So what does that do? Is that you're actually like switching the angles of your y value, so, and you rotate it 90 degrees, meaning it's going to turn around. This is like pretty complex. I just found that as a solution, and it would be a bit complicated to dig into that too much, so I'm just going to stay just on the surface for now. So what does that do now? Well, I like it better for a thing. Look at that. We have our biggest categories, so peak views and average views, and they're all converging towards here, like the very big channels that are very few. What's interesting is that you've got like a lot of channels in this category. This is by far the most populated category, so it's people making like 500 views or something, which is like already a lot, and those people tend to have like big peaks, and I guess for events, new games releases, party games with famous people. But what's interesting would be to now do that through time and see if like maybe some channels like tend to move up, or if they stagnate and the numbers like don't change really. I'm sorry, you should be able to move that around. For some reason I haven't been able to do that on Jupyter Notebook recently, but like, I mean, we are seeing well enough, so I didn't bother. I wanted to share that real quick and hope that it helps with 3D bar charts. It's not really complicated once you really understand this part. So what is x, y, z, d, x, dy, and dz? Obviously those are just examples I've seen people use many different names. I just like the fact that it's very clear that we're in a 3D bar chart and that we're referencing the same value here and here, or the same like factors. So I recommend using this notation. And yeah, so I hope this was clear enough. I hope that you enjoyed it, and I'll see you around. Bye.